Okay, Emilio is using pennies to make a pattern. He arranges his pennies as shown below. Figure 1, Figure 2, and Figure 3. Draw the next 3 figures in the pattern. Make a table to show the relationship between the figure number and the number of pennies. Well, if you study the figures, you'll notice that Figure 1 has one shaped circle on the bottom. Figure 2 has 2 circles on the bottom, so 2 and 2, and then it gets one less each time. So Figure 3 will have 3 circles on the bottom, then 2, and then 1. So what that means is that Figure 4 is going to have 4 circles on the bottom, and then you decrease 1 each time, so 3, 2, 1. Figure 5 is going to have 5, 4, 3, 2, 1, and Figure 6 will have 6, 5, 4, 3, 2, and 1. Then it says make a table to show the relationship between the figure number and the numbers of pennies. So what you have here is you have figure number in your table. That's first. And then you have pennies. And you just count them. So figure number 1 had 1 penny. Figure number 2 had 3 pennies. Figure number 3 has 6. Figure number 4 has 10. Figure number 5 has 15. And figure number 6 has 21. Okay, the next thing, graph the pattern on a coordinate grid and be sure to label your scales and your axis. Okay, whatever the first item is in the table is always along the bottom of your axis. So figure number is going to be on the bottom. And that means pennies will be on the side. Normally you write these sideways, but I can't with my board. Okay. So you always have 0 in the corner here. Okay, your figure numbers, you have to make sure that these lines are in even intervals. So figure numbers is easy. That's just 1, 2, 3, 4, 5, and 6. Now when you're going up the side, don't just copy the numbers from the table, because sometimes these are not linear relationships, and if you just copy the number of a table, it's going to look like a line even though it really isn't. So I've got to cover numbers 1 to 21. How many lines do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Got about 15. Let's go by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. So then you just follow your table. So 1, 1. So 1 on the bottom and then go up 1. That's about right here. And then for the number 2, you have to go up to 3. For the number 3, you have to go up to 6. For the number 4, and again I'm just following the table, you have to go up to 10. For the number 5, you're always starting on the bottom. You go up to 15. And for the number 6, you go up to 21. So as you can see, this is not a straight line. It's a curve, so it's not even a linear relationship. Okay, let me make sure I answered all the questions there. Notice I did not connect the dots because the number of the figure doesn't really necessarily have to do with pennies. Graph the pattern or coordinate grid. Okay, I did everything there. Okay, write the numbers of pennies as a sequence. A sequence is just a list of numbers. So all you literally do is you look at your pennies and you take all of these numbers that are right here, 1, 3, 6, 10, 15, and 21, and you write them as a list of numbers, like this. 1, 3, 6, 10, 15, and 21. And it could continue, so you put dot, dot, dot. Does your sequence have a common difference? Common difference is the same thing added each time, or subtracted each time. Well, for the first two, you're adding 2, then you're adding 3, then you're adding 4, then 5, then 6. That's not adding the same number each time. So it doesn't have a common difference because they don't differ by the same amount. So that's the answer to that part, is there is no common difference because they do not, oops, sorry. By the same amount. Okay, the next one. I think that's it for that page. Okay, Emilio is using a guess and check strategy to write an expression for the number of pennies in any figure. He writes the expression n times the quantity n plus 1, where n represents the figure number. Make a table to show the value of Emilio's. This is not the value this is not the same table we got on the other side. The value of Emilio's expression, this is his expression, for n equals 1, 2, 3, 4, 5, and 6. How does this show that Emilio's expression is incorrect? Alright, so here Emilio has the figure number and the number of pennies. And they've asked you to use 1, 2, 3, 4, 5, and 6. I think my board is having problems today. Okay, so for the first one, you've got 1 times 1 plus 1. I'm just plugging the figure number in for the n's on his expression. So that you have to do inside the parentheses first. So that's 1 times 2, which equals 2. Then you do the same thing with the 2. You have 2 parentheses 2 plus 1. So that's 2 times 3. That equals 6. And then for the 3, we have 3 parentheses 3 plus 1. That's 3 times 4. That equals 12. Then you've got 4 parentheses 4 plus 1, which is 4 times 5, which is 20. Then you've got 5 parentheses 5 plus 1, which is 5 times 6, which is 30. And you've got 6 parentheses 6 plus 1, which is the same as 6 times 7, which gives you 42. Okay, that's Emilio's table. And it says, how does this show that Emilio's expression is incorrect? Well, if you compare it to the table that we got on the other side, it doesn't, Emilio's expression does not give the correct number of pennies in each figure. So that's the explanation for that one. Okay, the next one. Compare the values you found for Amelia's expression in part A to the number of pennies in each figure. Use what you used to observe to modify Amelia's expression so that it's correct, and explain your reasoning. Well, on our previous page, the number of pennies, instead of 1, Amelia got 2. Instead of 3, he got 6. Instead of 6, he got 12. Instead of 10, he got 20. Instead of 15, he got 30. And instead of 21, he got 42. So if you compare the two tables, you will see that Emilio's table actually doubled it each time. So what we need to do is we need to take his expression and then cut it in half. So here's the explanation for all that. Emilio's expression does not give the correct number of pennies in each figure. Therefore, I'm typing the wrong one. Amelia's expression gives values, I'm sorry, looked at the wrong thing, gives values that are twice the number of pennies. That's what we talked about in each figure. Therefore, divide his expression by 2. Okay, so here's what the new expression is going to be, because here's Amelia's expression. Amelia's expression was in parentheses n plus 1. It was incorrect. We have to divide that by 2. Okay, the next one. How many pennies would be required to make figure 25? Well, now that we have the correct expression, in parentheses n plus 1 divided by 2, and I'm going to change that to be 25 times parentheses 25 plus 1 divided by 2. So that is 25 times 26 divided by 2. Now let me show you something. The easiest way to do this is to figure out what take an even number up here and divide it by 2. So half of 26 is 13. So we can say 25 times 13. It just makes it a little bit easier to multiply it out. And 25 times 13, let's just do this real quick here. $3.25. So it would take 325 pennies. Okay, the next one. Suppose that you have 100 pennies. What is the figure number of the largest figure in Amelia's pattern that you can make? Will you use all 100 pennies, and explain? Okay, so 100 pennies. Let's just start with 13 times 14 divided by 2. Because I know that 14 divided by 2 is 7, and 13 times 7 is 91, so that gets me close. If you had 100 pennies but you used 91, there are 9 left over in that case. Let's say figure 14. So 14, n plus 1 would be 15 divided by 2. So 14 divided by 2 is 7. So this is like 7 times 15. That's 105. That's too much. We only have 100 pennies. So here's the answer. The figure number, the largest figure, figure 13, will have 9 pennies left over.